Howdy class. So today I'll be recording this lecture off of my newly issued Surface. The one I was using before finally kicked the bucket, as it were, and so I finally got this new one set up. So let's go ahead and work out this one. Today we'll be going over present value versus future value. As we've talked about, money does have a time value associated with it. $1 today is worth more than $1 tomorrow, even if you're not thinking about inflation, but inflation only makes that all the more prescient. So let's look at this. So A is considered to be a future value, while P is considered to be a present value. So we've been calling P the principal, which is perfectly fine way to think about it. It is also congruent with thinking about it as the present value. And so A is still the accumulated amount, but we'll be thinking about that in terms of a future value. Again, congruent with our way we've been defining it thus far. So here we're going to go ahead and rewrite our formula. A equals P times 1 plus the effective rate per compounding period to the NT. Remember, RE is R divided by the number of compounds per year. Alright, so all we're going to do is rearrange this equation. Actually, let me go ahead and show you the step that we do. We multiply both sides by 1 plus RE to the negative NT. 1 plus RE negative NT. Alright, and so what you'll notice is that on the right hand side, right, this times this, those go away. So all we're left with is P on the right hand side and so P equals A times 1 plus RE to the negative NT. And that's our formula. And this is important because if at a later date you want to know how much money you'll have in your investment, or if you know how much money you want to have in your investment, should I say, you got to know how much money to invest given all these other factors. So let's go ahead and look at this example here. Alright, so in this example, we're going to invest my money into an account. This account gives us an 8% rate of return per year. And we want to have $25,000 after 6 years. Alright, so let's go ahead and work this out. First, we got to figure out what is RE. And RE equals 0.08 with a compound period of 12, right? Because 12 done monthly. So let's write our equation here. P equals the amount that we want to have plus times 1 plus RE to the negative NT power. So filling all this in, again we want 25,000. 1 plus, and you can calculate that beforehand or you can just write it in like that, doesn't matter, it's fine, to the negative, and we had 6 years times t, times n. Let me go ahead and get this in the same order here. 12 times 6. If you did it the reverse order, it would have been fine, but just for clarity's sake, I'm trying to keep everything nice and uniform. So again, there's that one. Oh. Put that one there. And 25,000, that was in the blue highlight. Yep. Alright, so when you calculate this through, you will get, and so here we have $15,494.24. That is what you will have to invest in order to get $25,000 at the end of the 6-year term. So let's go ahead and write that out in a sentence format. This is what you'll have to be doing as in whatever business you find yourself in. So you would write in order okay, there it is. In order to have $25,000 in an account bearing 8% annual interest in 6 years, comma, you will need to invest $15,494.24 now. Okay, just so I can have an idea of what's going on. Of course, it's compounded monthly. Usually that's assumed, but you never want to just make assumptions because it could be compounded quarterly. That always is a possibility, or some other concoction that people have come up with. But typically it will be monthly, but not always. So keep that in mind. All right, so that's how this equation is used. Now let's go on to amortizing a loan, and this is really important because most loans do involve a payment. This is also if you were to get some kind of interest-bearing account and it paid you out. This is pretty much the equation that would be used. So let's go ahead and run through this. We begin by looking at what's going on, which is going to map out the cash flow, right? There's some principal, a present value. And here's our timeline. Put a little cut in the timeline, and then we have like the last bit, so we'll call that the last compounding period M. And the rate will be R. We'll call it RE, because it's going to be per compounding period. And so you get one payment at R, and it's at, at 1, and then at 2 you get another payment of R. At 3 you get another payment of R, and on it goes. So these are all the same. Put a little break in there until you get to the last one, which again is at R. And this would be the one right before it at M-1. All equal payments. And so you could kind of think of this as the minimum monthly payment for your credit card statement. So let's go ahead and write all these out. So our present value equals R times, and it's going to be a negative exponent, so we'll go ahead and put it in the bottom. One plus RE, right? It's R times 1 plus RE negative 1. We just stuffed in the bottom. That's okay. And you know what? I'm going to go ahead and push this over to give ourselves a little bit more space. Add the next one, R times 1 plus RE, and this time, you know, it's a square root. Again, all we're doing is using this equation right here. Right, to the negative nt, where, of course, this a value we're reinterpreting as R, right, because it's a future value. Okay, and so then you kind of do a whole bunch more of these. R times 1 plus RE, m minus 1, and then you get to the very last one. Negative m on the bottom there. Alright, so we're going to do something that's a little bit clever here. Let me go ahead and zoom in to our step here. We're going to multiply everything by what you see in the bottom, that 1 plus RE. So on the left hand side we've got P times 1 plus RE. And so you multiply this first term here, and note that you will end up getting R. Multiply this term by 1 plus RE, and you will simply end up with R over 1 plus RE. And then you'll multiply, the term that's over here, and then you'll get R times 1 plus RE squared. Do that for each and every single one of these. Do it for this one, and that'll cancel with whatever term is over here. And then you multiply this term, and you'll get R times 1 plus RE to the m minus 1. Alright, so we've got a nice setup here. And what we're going to do now is we're going to subtract these equations from each other. And so you end up with, on the left hand side, P minus P times 1 plus RE equals negative R. And then note that this term will cancel with this term, right? Minus this term minus this term. All of these terms minus all of these terms, and then this term minus that term. So pretty nice. Only two terms survive, the first and the last. So we've got our negative R plus R divided by 1 plus RE to the nth power. Alright, so now we're going to factor a negative P and a negative R out of each of these statements so that we've got 1 plus. Let me go ahead and move this down. I'm running out of space here. Alright, so that's going to be, 1 minus 1 plus RE to the negative M. Okay, and let me go ahead and just make that a bigger parenthesis so it's a little more visible. Because we got a lot of parentheses acting there. So, alright, so notice what we have. Negative 1 plus 1. Multiply both sides by a positive to get rid of that. And on the left hand side, all we're left with is PRE. And then on the right hand side, we have R times 1 minus 1 plus RE to the negative M. And so notice that you divide both sides by this quantity here, and you'll end up with that equation right there. And I have it set up as PMT instead of R. That's because typically if you look in your credit card statements, you'll see the term PMT, minimum payment, all sorts of different ways to describe it. But anyways, we'll be using the letter R. But I just wanted to make you guys aware that, there are other letters that people use to describe this. And so let's use this to move on. We're going to use this to amortize a loan here in a little bit. Basically, what will appear when you look at a credit card statement or a car loan. First, let's take a look at this example before doing that, though. We're purchasing a $15,000 car. The bank is offering us a rate of 5% for 3 years. Calculate your monthly payments. Okay, so we're just going to use the equation, which is again R equals PRE 1 minus 1 plus RE raised to the negative NT. And so again, what is RE? RE is 0.05 divided by 12, right? It's done monthly. Now let's go ahead and calculate this through right now and get 0.0041666666, right? That line over there, the 6 just means it's repeating. So we want to make sure that we include that when we're typing in our calculation. And I think everything else we have, so let's go ahead and put all this in. So 15,000 okay, and then raised to the NT. What was the number of years again? 3. So we'll put a negative 36 there, right? 3 times 12. So we'll multiply it on the top, 62.5. And in the bottom, 1 minus 0.8 60976. Okay, 2. Got that second one. And then from here we just can perform that final calculation to find that our minimum monthly payments will be $449.56. And you'll round to the nearest penny at this point. You just want to maintain all those decimal places for all of your intermediate calculations, but at the very end you only record down to the last penny. And that's it. So that's, let's go ahead and add per month. And so that you'll be paying about $450 every month for the next 3 years of your life if you purchase this car. And so that's kind of just the cost of getting the car beforehand will be the interest. Note that if you multiply this number times the number of compounding periods, the number of months in 3 years, right, you multiply by times 36 months, and you will end up paying a total of $16,184.28. So note that that would be $1,184.28 that extra that you will be paying on top of the price of the vehicle. And so that may seem to some of you, maybe that seems unfair that you have to pay more than the value of the car, but think about this. The person you're loaning from is having to do without that money during that period. And so we are getting to use that cash 3 years before we would actually receive it. And so that is the cost of getting money before we actually have it. Now, it's worth noting that early on when you're making payments, most of those payments go towards paying the interest as opposed to paying the principal. So let's go ahead and explore this a little bit by amortizing the loan as promised in Excel. Alright, so let's go ahead and record all of our inputs. So here again we got the principal, which was $15,000. Right, because that's what we're borrowing for the car. And this was at a rate of 5%, and that was per year. And so this was monthly. So that would be 12 compounds per year. And the term was 3 years. Alright, and so let's go ahead and highlight these in yellow. And the highlight yellow part will just be our inputs. So if we want to play around in the spreadsheet by changing those inputs, we'll know what to go for. So let's go ahead and calculate everything now. So RE that's going to be our interest rate per compounding period. And so that is R divided by N, compounds per year. And then let's find our total number of compounds. We call that M. And so this is just N times T. Okay, and notice how we're breaking up the intermediate calculations. We don't want to do too much in one cell because then it becomes very hard to see if an error did indeed occur. Alright, so we got that one, and let's go ahead and find the top, right, that's P times RE. Like so. And now let's find that term, one of the terms in the bottom anyways. 1 plus RE raised to the negative M. So 1 plus this guy raised to the negative M. Okay, so we basically now have all of our inputs to check our calculation for the monthly payment. So let's go and do that. So our monthly payment, big R, equals the top amount divided by 1 minus this guy here. Right, which is what we got before, $449.56. So let's go ahead and highlight that in red, since that is our one of our main outputs. We'll also be outputting with this one. That's a little dark. Let's, yeah, orange is a little bit easier to see. Alright, so now let's go ahead and amortize this loan. We're almost there. So first thing we do is we set up which month we're in, or which compounding period we're in, right? So 0. We'll start off there. And then the next one will be 1, so I'm just going to say equals 1 plus the previous one, so that way it's always increasing by 1. Put down our payment right here. First month, you don't pay anything, unless you have a down payment, of course. And then from then on out, we'll just assume minimum payments. And again, note that if I grab this and scroll down, first one is fine, but the next one is down below it. One more below, one more below, one more below, and one more below. I want to be able to just drag it and keep that in place. So in order to do that, I put a $sign in front of the number. I'm going to go ahead and put a $sign in front of the letter as well, because I want to hold both places, because we're going to be using this setup to explore a couple of different scenarios. So now note that if I scroll down, everything stays as it should. Okay, and the only difference between this and a credit card statement is it'll have actual dates. Here we're just going off of some arbitrary start date. Alright, so right here we're going to calculate any new interest. Okay, that's a capital I. I know it looks like an L with this font, but that is what it is. First month you get no interest. And let me go ahead and come over here before going forward. We have our starting principal, which of course is that one right there. And so our interest will always be whatever the principal was from the previous month multiplied by our rate per compound period. Don't forget to put a $sign in front of the number, and we'll do it in front of the letter too. Alright, now the principal. So you take the previous principal, you subtract out what you paid, but note that you have to add back in the interest accrued, and so that's why we say that initially particularly if it's a bigger loan, like for a house mortgage, majority of the payment, a good portion of the payment, will go towards paying down the interest and not the principal. And then as you pay the principal down, then you get more and more what you're paying off. Less of the interest and more of the principal. Particularly if you have a high enough interest rate. And we'll be, again, playing around with different scenarios. And so let's go ahead and have a total interest accrued. So initially it's 0, and then we just start adding in all the interest. And then have one for our total payments. Okay, and just a running total right there. Okay, as long as we didn't make any mistakes, everything should be running through fine. Okay, good. And so the good way to test this is when you get to month 36, our principal should be 0, right? Because then we're done paying the loan. As long as we make minimum payments, not more, not less. All right, and there it is, right there. Balance principal is 0 right here, and that's what we're looking for. And there we have it. We've just amortized the loan. So if you ever wonder where all those numbers come on your credit card statement or car note statement, this is how everything is generated, just with these equations and running an Excel sheet. So let's do a little analysis of this. We're going to say here we'll look at it as percent of payment to the principal. Okay, so that's simply going to be, well, the first one kind of doesn't matter, so we'll look at the second one, or month number 1. So the total, the amount going to principal is simply the difference between the amount that's being paid and then you subtract out what's going into the interest. Divide that by the total payment, and we got 86% right there. So that means that 14% of your payment is going only to interest, and only 86% goes towards paying down the balance of the loan. And you see as you okay, yes, I see what happened here. So let's grab this one here, and we go down. There we are. And you see as you go along, that rises and rises till you finally get the last payment, which goes 100% towards what you owe on the loan. So let's look at this graphically. Alright, so for this graph, come over here, right click in there, and we're going to select our data series name. This will be simply, we'll make it match this guy here. X values, right, that's going to be which number month we're on. And the Y values is simply the percent that goes towards the principal. Okay, and this point right here is just for the very first one, that is 0 because there is no payment. Alright, so let's go ahead and move this. I'm recording a video, kiddo.
Oh.
Alright, and so we move this over here. And there we are. So again, notice how it's just kind of a nice progression on the way up. So here we can play around with a few things. This is with 5% interest. Let's see how this changes for higher percent interest rates. So here we have at 5%. Let's make it 10% per year. Right? The number of months stays the same. All we changed was the rate. And so you can see it was definitely progressed, but a little bit more slowly. And let's change another one. Let's see, not 10%. Let's make it 17%, which I believe is the current definition of anything above that is considered usury legally. And you can kind of tell it's not quite a straight line. There is a bow in this line, so oops, whatever news sources those were, and so it's more pronounced when you have the higher interest rates. Let's go ahead and see how this plays out if we have more payments, right? A longer term. All right, and so we're going to go ahead and Control C and move this over to the next sheet so we can run another scenario. Alright, so this is all what we had previously, just simple copy and paste. And so let's go ahead and change the years from 3 to 10, so we can kind of see what happens with more extreme numbers. And note that the number of compounds is up to 120. And so note that here we only go to 36. You even look at where we stand with the principal, which is not at 0. So let's go ahead and fix this. So just, oops, select that here. And we're going to get this all the way down to month 120, so a little bit further to go. And note that we're now at 0. Balance. Okay. All right, and so this was the interest, $16,283.58 with the amount of interest, resulting in total payments of $31,283.58. All of this is for, again, a $15,000 loan. You will more have doubled how much money you had to spend to get that asset. But that is the cost of getting the money early when you did not have access to it before. So let's go ahead and we'll go ahead and take a note. This ends at row 134 because we want to fix our graph. So all we're going to do is we're going to select this. We want to select the data and edit. replace that with 134. Replace that with 134. Okay, and so now you can see how the curve is different. That the same bend was present in the other graph. It was so subtle that you weren't really able to see it, but here very pronounced. As you can see, principal starts off 20% and grows slowly, but as you reach the end starts to increase how much principal you're paying down. So always keep that in mind when taking out a loan, that if you're able to make early payments, it will in the long run. For instance, if you pay a couple $100 extra, the money on top will go directly to principal, and that will ultimately end in a lot less interest over the lifetime of the loan. So I hope you've learned something from this. Make sure you apply it in your decision making when it comes to taking out loans. And I definitely encourage you to, anytime you're considering a loan, do your own calculations. You know, like we've done with this Excel sheet, amortize the loan. It really makes a difference. If you have a credit card statement, run this through and make sure that you can duplicate what's on the statement using an Excel sheet like this. It's a very good practice. I very highly recommend that all of you do this. So in the end, that's it. Have a very good day, and I will catch you guys next time.